So good afternoon, everyone. Hope you are able to see my screen. Can anyone of you confirm? Are you able to see my screen? Okay, fine. Hope you are able to hear me. Yeah. Fine. So at the outset, let me thank you for joining this webinar series on the neural networks that is part of the deep learning. Just we'll do the quick recap of what is being discussed in the last class, and then we'll take it further in today's class. So in the last class, that is the last session, we started with the introduction to artificial intelligence, and then what are the applications of artificial intelligence, and why should you learn artificial intelligence, and introduction to neural networks, and hands-on using artificial neural network. In today's session, we'll talk about the CNN, that is convolution neural network, and there is a small change in terms of the topic. So tomorrow I will be covering the use case, and today I will be covering the CNN, that is convolution neural network, so that that would help us to solve the use case. So today we will be taking up the convolution neural network. And as we discussed in the previous class, artificial intelligence is nothing but it is also called as the machine intelligence, which is the intelligence which is being displayed by the machines in contrast to the intelligence that is being displayed by the human being, right? So a machine can mimic the intelligence of a human being? That is what is the artificial intelligence in overall understanding, and it is basically going to mimic the cognitive function. So we have the great ability in terms of understanding and then learning and then solving a problem. Can the machine do this? That is what is the branch of the computer science is called as the artificial intelligence. And then we went through different things of the artificial intelligence, or the different branches of the subset of the artificial intelligence. So overall, any technique that enables computers to mimic the human intelligence is called as the artificial intelligence. In that, one subset is the machine learning. So where we will be using some kind of statistical techniques to enable the machine to improve the task with the experience. Like as a human being, if we do the same task multiple times, and we are able to do the excel in that task, and maybe a different set of tasks also we are able to do it. So that is what we call it as the machine learning. In case of the deep learning, performing the task using what you can call it as the neural networks. So just to simulate the way biological neural network of the human being works in the same. Sorry. Sorry.
It's registered only. It's showing start the broadcast. Registered only, Mohan. It is registered, it's automatically going to that live room only. They can start the broadcast. After they register only to come only. Otherwise, I'll share you the that live room link in that mail only. Yeah, sure. Omar.Mike, right? Yes, yes, right? Okay.
Can you can you
You
un-
are all I can GRAJIN. Yes, sure, 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 sure.
can you unmute
Yeah,
when
bro.
you're talking?
I'll, I'll send them that live room link only. Yeah, sure, sure. Yeah, yeah, sure. I'll share as soon as possible. Yeah. Hello? Yeah, bro.
Hello, can you unmute when you're talking? Otherwise, I am not able to talk. Vinod, can you unmute yourself when you're talking? Okay, sorry for that disturbance. Hope you are able to hear me. Yeah. So we were discussing about the different subset of the machine learning, which is, artificial intelligence, machine learning, and the deep learning. So in the last previous session, we started with different kinds of deep learning, where we discussed about the and also about the different kinds of applications or classifications of the AI. So AI could be used in natural language processing as well as vision in terms of image recognition, machine vision, and also like speech to text, text to speech, robotics, like, so we have discussed this thing and different possible applications of artificial intelligence. So which are like starting with personal assistance, natural language processing, simulating, as well as machine translation, social network analysis, robotics, Internet of Things, audio analysis, image classification. So multiple applications of artificial intelligence. So then we discussed like why there is so much buzz about deep learning or so much about the about this neural networks. So the reason is one is the growth of the data. So compared to 5 years ago and now, there is a lot of data coming from the human being as well as machines are also generating data. And also there is a advancements in the hardware, right? There is an advancement in the hardware. So we are getting a good hardware, good processing ability. Also, if not, you can use the cloud for that purpose. And the ecosystems which are built on top of Python and all the open sources associated with Python, which are helping us to work on or take up any use case and solve it and work on this. So these are the main reasons of growth in the this thing. So that is where we started, and then we started with the types of neural network. That is the artificial neural network, convolution neural network, and recurrent neural network. So today I would be discussing about the convolution neural network and how actually what is the meaning of convolution, how it works, and things like that. Okay, so that is the setting the context for today's session. So let us go ahead with the convolution neural network. So that is what we would be doing, say introduction to convolution neural network, and then how to build a CNN, and the on the hands-on session like image classification using CNN. So what is the problem with ANN, artificial neural network? Or ANN is good, like if like solving simple classification kind of a problem where digit recognition and all, it's okay. But as the image size increases, if we use the ANN, we need to do a lot of calculation, right? We need to do a lot of calculations if we want to use the ANN, because suppose there the previously we have taken the image size of 28 by 28, that's okay. So let us take this example where this animal, this is called koala, and this is found in Australia. And if this, say, look at this image, and its size is 1920 by 1080 and 8 to 3, that is RGB, for 3 for RGB. And if we have multiple layers, again multiple layers, and the neurons in the first layer itself is around 6 million, that is the input. And then if we have some hidden layers, then again we have, let us say, even though I reduce the number of number size, but still it may be around 4 million. And then we have to use the weights between the input and the hidden layer, and if you look at this, it's around 24 million. So it's huge computation, so a lot of computation is there. So in those cases, this ANN will get very slow, and it's really it takes a lot of time to do that kind of a processing. So that is where this convolution neural network comes into picture, and it is very good for the image classification or image processing, right? So that is where we will be using the CNN, convolution neural network. So what is the disadvantage of using ANN for the image classification is, one is the too much computation, and second one is treats local pixel same as the pixels far apart. Suppose, say, if you look at the face of this particular animal koala, so even if this tilts the face, like other side or this side or the other side, still the face is a face. Okay, but with the ANN, it is difficult to like identify this in that scenario if there is a change in the location. Okay, localization. So that is where there is a problem. It is not able to recognize it properly, and sensitive to the location of an object in the image. Okay, so again it is very sensitive, like if those images, the position of the face, if it is at the same position, probably it may be able to locate, and if there is any tilting or twisting or any kind of a transformation, so it's not able to do proper classification. So these are all the few of the disadvantage of using the artificial neural network. So let us see how can we use the convolution neural network to overcome such kind of issues which you face with the artificial neural network or ANN. So the first thing is the feature detection. Remember, like yesterday also we were discussing about the feature detection. So when we look at the image, how a human being recognizes that particular image, and how it is going to identify whether this is a plant or an animal. If it is an animal, what is the name of a specific animal, even though there is a variation in the size of the animal or maybe the shape of the animal, still it or the color, bit color, still it is able to, we are able to identify. So that is what we call it as the feature detection. So the feature detection, as I told you in the previous session, so first we are going to identify the features. That is what are the features here? Let us look at the koala's eyes. Okay, so koala's eyes, and then koala's nose, this is a feature. The ears, the fluffy ears, it is a feature, right? So first we are going to identify the features, the koala's hand, the koala's leg. So we are going to identify these features, and from that feature, again, we will further, once these features are identified, again in the next layer, what we are going to do is we are going to identify whether it is the head of a koala or a body of the koala. So if this is fine, and then finally we are going to decide whether it is a koala or not. So the first thing is the feature detection. So how do we go about detecting the feature? So as a human being, we do it very quickly, but what about the machine? How it is going to identify the feature? Okay, so that is what we will be looking at this. So this is where, when I say when we are building a neural network, so which has multiple layers, multiple hidden layers, and then those layers are connected to each other, and each layer further filters, and then it takes us near to the our object of detecting whether this is a particular animal or not, of something of that sort. So a machine detect this particular number? Let us say if it is number 9. So first we have to identify the pattern, right? What is the pattern? So if you look at 9, what are the different features? Like one is on the head, like this particular portion, and then like curve here, and then down bottom, and then the straight line, and then diagonal line, and things like that. So again, in each of the layer, we are going to identify these particular features, and then when we put the features together, so let us say in this next layer, are we getting this loopy pattern? Okay, this is the loopy circle pattern. So if I put them together, this is the vertical line, and then finally the diagonal line. And then when I put them together, so I'm going to get this particular number 9, right? So this is how we are going to uh, identify the feature and then put them together and then try to see whether that particular number is a 9 or any other number. So this is what we try to do. That is what is called as the feature detection, right? So for that, we will be using what is called as the filter. Suppose if I put 9 and finally it's all boils down to what? Mathematics, right? So I can put them, I can convert this into a number. I can convert into a number. So look at this particular 9. See all this portion where there is this 0 is there. So the values are like 1, and here there is nothing is there. The value is -1. Similarly here, see outside you have value of -1, and things like that. So here also -1. So we try to identify the filter. Uh, First, we will identify the filter, and then we have to represent them mathematically. So we have to identify the different filters here. So this is one of them, and then you can see as we have identified the vertical line. Vertical line means so it should have these things like 111, and then diagonal line like 11, things like that. So we are going to convert this particular into a number. So this is what we will be doing. So now the question is, we are going to apply what is the operation called as a convolution. Okay, so what we are trying to do is we have to apply this pattern. See, now the thing is, how do you identify? How do you identify 9 is in this position? So 9 maybe when I am writing, I may tilt 9 something, or I may move the 9 differently. Suppose I may start writing the 9 from the left top corner, or I may start at the middle, or I may start writing the 9 from the right top corner. Still, it should identify it as 9, right? So whichever the way I want to write, or so maybe I will write a smaller 9. Okay, so I may start from here. Okay, so still it has to identify this as a 9. So then how it is going to do is we know, like, first we identify what are the different filters. Then what we do is we pass that filter through this particular matrix, and then get the value. Try to identify that particular each filter by doing some mathematical operation. So that is what we are going to do. So the first thing what we are going to do is the convolution operation. What we do is first we will identify a filter. See, this is the filter. This filter is used for what? It is used. This filter is used to, so this one. This is used to identify the 0 in the 9. Okay, so this part it is used to identify the 0 in 9. So this filter is like 111, 1 minus 1, 1 minus 1. So what we do is we pass this filter, like we take this filter, and then we try to multiply that filter with these values. Okay, so this is the image of the 9 or whatever the number, and then here you have set of -1, 1 and all. We try to take this and then we try to multiply this. Suppose I -1 into 1, that is -1. Similarly 1 into 1, 1, like this. 1 into 1, 1, like each row, here the first row and the first row of the filter, like this we keep on multiplying, and then we add all those things. And then try to divide by the number of houses here. Okay, number of pixels here, number of houses here. So that is totally 9. So this is the way we try to identify, we apply this particular filter, and then once it is done, then we move it. We move here next. We move this to the next house, and then keep on moving to the next house, and then we will be getting this particular, what you can call it as matrix. So where this is now 3 by 1, 2, 3, 4, 5, 6, 7, and then 7 by 1, 2, 3, 4, 5. So that is converted into 1, 2, 3, 4, 5 by 3. Okay, so this is what first we do, what is called as the convolution operation. So I'm just explaining you like how how any machine can identify the image using this kind of various operations. This is the first operation, namely the convolution operation. So once we keep on doing that, see, first we have taken this, and then we took the value. This is -1, then we move it here, and then we calculate the value. See, this exactly matches here. So if we are able, if the value is near to 1, that means that we are able to identify this particular pattern here. See, we are able to identify this pattern here. Other places the values are different, right? So this is what we do. This is what we call it as the feature map. So the feature map is basically to identify the features of the image. Like that, what we do is we will be identifying the feature map using the detectors. Okay, detectors we are going to identify. So this is the detector for this. Okay, 1, 1, -1, and then when we apply, we got, okay, so this pattern like 0 of the 9 is here. Similarly, if we apply this pattern for this number 6, see, like it comes here like that. So when we apply that loopy pattern detector on the I8, so you can get this feature here and here. Similarly, 9, 6. So if it is the number is 9, 6, then you will identify this. So this is what the first operation, we call it as the convolution. Okay, so this is what we try to do. So filters are nothing but the feature detectors. So the features are detectors, like in normal machine learning, we have to identify the features. But in case of the convolution neural network, so it will identify the features. So you need not to worry about it. But how it is going to identify, that is what we are discussing here. So these are the feature detectors. Similarly, now let us moving back to this particular animal. Earlier, just I tried to explain with the number, so how the features are detected. So here, look at this. So many features, like we are going to again apply this filtering operation. So we are going to detect the eye here. So eyes may be oriented like this in this case, and this is the feature detector we are going to do. And see, in this case, the eyes, see here, the eyes at bit height, but here in this case, like it may be just at the midpoint of this particular rectangle, and still it is going to detect the feature. That means location invariant means what? It can detect the eyes in any location of the image. If a animal is like tilting its head, or it has moved its head up or down, still this way, if we apply, this is meaning location invariant, still it is going to detect the eyes in any location of the image. So that is what it is going to do. And other than that, what if I have many animals? Like, see, so many animals are there. So, but I know the filter for the eyes. Okay, so even though you have many, see, still it is able to identify. See, the here one, only on the right eye it is going to identify, and then 2 eyes, and then here 2 more eyes, right? So that is what is the meaning of location invariant. This problem was there in the ANN, and this is going to overcome those issues, and this is what is the location invariant, right? So this is what it is going to do. And like this, we apply the different filters. See here, for getting this loopy pattern filter, this is the filter I am going to apply. For the vertical line, see here, all are 1, 1, 1 at the center, and then -1 surrounding the center. So this is where I'm going to get this. And similarly, the diagonal line, see the diagonal detector. So here again, the values are different. You can see here -1, -1, 1, 1, 1. So this is on the diagonal. So this is what we are going to identify, and then we are trying to identify what is called as the diagonal line detector. So this is, and then we put them together. This is called as the feature map. So there are so many features of that particular image we are going to identify, and then we are going to stack them together. So this is what is the first operation, which we call it as the convolution operation. So then if you put them together, like for example, in this case, this is the eyes and the nose and the ears, and put them together. So this is the filter for the head, and then filter could be not necessarily 2-dimension, it could be 3-dimension also. So then we are going to get this, identify the various parts of the image using the filter, right? So then once it is done, so this is what is the convolution operation we are going to do. Convolution operation we are going to do, identify the various features, and then identify the head and body together, and then we get this particular matrix. Then we are going to flatten it. So this part already we discussed on the yesterday's part. This part there, where you have the flatten, and then various hidden layers and all those things we are going to do. So this part is what we will be doing in the convolution neural network, but still there is a problem. Still, we have the size of the image is not still drastically reduced. Still, it is big. So we need to do something more in order to make identify the image bit faster. Otherwise, it's going to take a lot of time to process it. So for that, we will do some other operations. So let us see what are the things we are going to do further, so that the image classification would be made faster, or to overcome the issue whatever we have faced in the ANN. The next thing is, what we are going to do in this case is, after we use the loopy pattern, then we are going to convert this non-linear linear stuff to non-linear, meaning we can apply some of these things. One is the ReLU. Okay, ReLU, what it is going to do is, if you pass any number to this, if it is a negative number, it is going to convert it into 0, so that the number of computation when we do will be reduced. And second is, if any number which is positive, it is going to keep as it is. Okay, so this is the second thing we are going to use any of this. So in this case, just for an example, we are using a ReLU operation, and where these any negative number or any negative number is converted into 0, any positive number will remain as it is. So this is going to get the non-linearity into this. So the next is, ReLU helps with making the model non-linear. Okay, this is what we are going to do. And then we are using another thing called as pooling layer, used to reduce the size. So these are the things which we wanted to overcome the issues with the ANN. So that is what we are trying to do. So here it is trying to reduce the size. Now the question is, how do you reduce the size of this particular image or the matrix, still making keeping those features intact? Because features already we have identified it, but still we have to keep those features or the filters intact, but still we should try to reduce the size of the size, so that the computation could be faster. So that is what we are going to do in the pooling layer. So there are different pooling layers are used. One is called as the max pooling, and other could be like average pooling. So in this case, what we are going to do is, like, for example, if finally the values, whatever we are getting, suppose say if it is 5, 1, 1, 8, 8, 2 and 3, 4, 9, 2, like this, what we are going to do, and also we are going to use the filter of 2 by 2. Suppose I am using 2 by 2 and then stride with 2. So after this, I will move here, then here and here, this particular filter. In case of the max pooling, we are going to take, we want to reduce this size, right? It is now 4 by 4. I want to reduce it to 2 by 2, so that computation could be faster, but still I wanted to keep those filters values intact. So then one of the way is the max pooling. Max pooling is nothing but getting the maximum value in this particular filter. So 2 by 2 filter in this 8512, the maximum value is 8. Similarly, here 3492, the maximum value is 9. Like this, the maximum value is 3 and maximum value is 2. So this is what we call it as the max pooling. Okay, so this is what we do in this case, the max pooling. And then the filter style could be like, we can decide like what kind of filter we want to use, whether it is 2 by 2, 3 by 3. Those are all fine, but this is how the max pooling is going to work. And then with that, what will happen is even the shift, if we keep on shifting the location of the 9 to a different position also, then there won't be a much problem. So first what we are going to do, we are going to use the loopy pattern. Let us take again the example of this 9, and then what we do is first we will apply the loopy pattern filter, and to identify this portion and see, we can see here it is 9, and then we apply the value function, and then still it is here, and then we are going to use the max pooling. The max pooling, see here 10.11 and then 0, it is 1, then 0.33, it is 0.3, like this. So see this gradually the size of the matrix is reduced, but still keeping the loopy pattern values intact, or still we are able to identify this. In this case, yeah, this is here, so this we are keeping intact. So that is what we are going to do with the what is called as the max pooling. Yeah, even though if we shift to a different location, then there is no problem. Sometimes they are also using the average pooling. What is the average pooling? Suppose say 5 plus 1 plus 2 plus 8 by 4. Okay, that is also average pooling. It's in this case it is 16 by 4, which is 4, like this. So the either use the max pooling or the average pooling. So this is what we do. So the why we are doing all these things? So just to overcome the issues of ANN. One is the benefits of the pooling is to reduce the dimensions under computation and reduce the overfitting as there are less parameters. So if there are too many parameters, then it is overfitting. It is said to be overfitting. Okay, so that may work very good in case of the training data, but when it comes to testing data, it may not work, right? That is what we do, like in case of the overfitting. And then model is tolerant towards the variation and the distortions. Like if there is a variation, still it is able to identify. If there is a distortion, still it is able to identify. So these are the few of the benefits of pooling. Okay. So then, so these are the process we can have, and then here there may be. So finally, your neural network would be something like this. This is the animal. First is the convolution, value operation. Then it has detected eyes, nose, ears, and then next again pooling. So again pooling, the size is reduced. Again you can go with the convolution value, and then head and body, and then again going pooling, and then whatever the matrix you get, then we are going to flatten it. We are going to convert it to a one-dimensional array, and then we are going to check whether it is a koala or not. So these are the things which will happen in case of the convolution neural network. So this is a bit different from what we have done in the ANN. Okay, so in case of the ANN, this is not we have done. So if you look at previous slides, in case of the ANN, if you look at this is what we have done, or we have introduced some kind of a hidden layer, and this is a fully connected. So in that way, CNN is better, and it has a lot of advantages over ANN, and it is mainly used for image classification, where we are going to use the CNN or the convolution neural network. Yeah, so this is what we are going to do. So the feature detectors and then filters, and this is what we are going to do. Making the model non-linear, pooling layer is used to reduce the size, right? And this is what average pooling. And then the benefits of pooling, as I told you, like it reduces the computation and then overfitting, and then the model is tolerant towards it. And this is what is when we say a neural network, when we are going to say CNN, this is how it would be. So again, it may be like you can have multiple convolution plus ReLU or any other operations you do on this, right? So convolution connection sparsity reduces the overfitting because we are not taking so many features. Convolution pooling gives the location invariant feature detector, and then parameter sharing. Like once we know, like, okay, this is what is the filter, we can use it. You can use it for some other image detection also. So that parameter sharing. And when we use the value, it introduces the non-linearity, speeds up the training and faster to compute. And pooling reduces the dimensions and computation, reduces overfitting, makes the model tolerant towards the small distortions and variations. So this is what. And there could be other things like rotation. If we do the rotation, like if you write the 9 in this way, or thickness, if we increase the size of this, then the CNN by itself does not take care of this rotation scaling. We have to do some other thing called the data augmentation. So I won't be discussing that in this session, but there are ways in which these things can also be handled. What if the image is rotated or scaled? So what we typically do is we take those images and we tilt them, or we do the data, we call it as data augmentation, and we put it in the training and then see whether our model is going to pick those kind of images also, whether it is going to classify it. So we are going to introduce those kind of a thing when we are images when we are doing the training. Okay, so that is what we would be doing this. So now coming to the practical, so you are able to get it. Let me see. Okay, there are many questions. We'll take it at the end. Yeah, fine. Yeah, good to see many questions coming up. Yeah, so we'll take it at the end. And just to introduce you, like we will be conducting this kind of, other than the webinars, we are also conducting the courses. So if you are interested, you can register for this particular course. I will send you the details. So it is Python deep learning is around 60 hours course, and its actual fee is 15K, but it is discounted for the people who are attending the webinar. It's around 5,000, so it's 10% discount, and you can contact us to register for this particular course. Okay, so now going to the practical session. Again, so again, here I have this Jupyter notebook, because if I have to run each and everything, it is going to take a lot of time. So I will be demonstrating the prepared one, because the training and all, it is going to take a lot of time. So here what we are going to do is we are going to use this image classification, and we have some built-in data we are going to take, and we wanted to classify. So what are the images? We have set of images, like the first set of images are called as the aeroplanes. So the aeroplanes of different what you can orientations and then shape and sizes here, and similarly automobiles. Right, we are going to train our model on these images, and then we will see, like, whether whenever I feed in any new image, whether is it able to classify it properly or not. Okay, so that is what we are going to do. And then we have the images of the bird, cat, and many images. We have the dog, frog, horse, right, ship and truck. So where do we get these images? And again, we have to import the library. So here we are going to use this TensorFlow, and then we are using the data set in the TensorFlow, and we are importing the layers and the models and matplotlib for plotting, and then the numpy for any of the matrix calculations or array calculations. So the data set is available. So this is available data set from TensorFlow Keras. We have this data set CI FAR10 load data. So when we load the data, again, you can get the you can get the train data and the testing data. So in case of the machine learning, as you know, like the data set, we are going to divide into two parts. One is the training data, another one is the test data. So using the train data, we are going to train our model. And then once the model is trained, once we have fine-tuned all the parameter and everything, you can go for testing to check whether the model, whatever you have built, is it predicting properly or not, right? So when you look at this data, here again, like the size, so we have around 50,000 images here, and then it is a training. It's a training 50,000 images, and size is like 32 by 32, and then C, this is the RGB. So then X test shape is again 32, 32, 3, and again it is around 10,000, right? And then you have 50,000 images and then 10,000 test images, right? So if you look at the first five images of the train, so then what are those images? That is the Y train. Okay, X, and the Y, it is the label data, right? So it is going to say this is the image with 69941. So the images are six, meaning like the sixth one here. So if you can see the first few images are six, means for few of them is like 1, 2, 3, 4, 5, 6, like this. So this represent 1, 2, 3, 4, 5, 6. That is the dog image, like this. So in that the sample five images are, one is the dog, next to are 9, which is nothing but the ship, right? And then you have four. The image four is nothing but 1, 2, 3, 4. That is the cat, like this. So you have the first few images are one. So one is nothing but the aeroplane. So just we are trying to see like what are the first few images here. And Y train is a 2D array. So our classification having 1D array is good enough. So we can convert this into 1D array. So this is a 2D array. 1D array is enough because you can do the reshape and you can get these values. Like this is the 1D array. So 96991. Okay, similarly, you can do the Y train and Y test also. And now we are going to see the classes. What are the classes like aeroplane, automobile and all? So you can just take those classes. And then we wanted to plot some images, see like how it is going to do. So then we can write a small function called plot sample, and then you pass the X train and the Y train and the index. Index is nothing but the image, which is like the image. It is like assuming so many images are there. Each index is nothing but the position of the image in that. So it is like a list in that. What is the position? So zeroth position. What is the image is there? Suppose I wanted to do, and then what we are doing, we are class plot.x label classes Y of index. So it is going to say like, oh, what is this particular class? It is going to label it, and then it is going to show this image. See, this is the image of a frog. Okay, so we have this particular image frog like this. So the second one, like one, this is the image of a truck like this. Okay, so the next thing what we do is like we are going to do the normalization. So images, we wanted to get it in the range of 0 to 1. We have like RGB values up to 255. So we wanted to normalize it. So we are going to divide this by 255. So that is what we are going to do. And then first we are going to build a artificial neural network, and then we will go for the CNN. So this is what we have done in the previous session. So we are going to use the flatten the data, flatten it. The input shape is like 32, 32, 3. And then we are going to use the three dense layers. One of the dense layer where we are going to use a different activation function. So we are using the ReLU for one, another one for ReLU, and then the final one is like sigmoid functions. These are the different activation functions which we use. Like it is similar to the way our biological neuron activates. Similarly, we are going to use this activation function. It is just a mathematical function. So which is like in this case, sigmoid is going to give a value between 0 and 1. In case of the value, as I said, if you pass any value, negative value is converted into 0, any positive value remains as it is. Like, so this is what we are going to build. And then we are going to compile and we are going to use different optimizers. So here, as it is just a webinar, I'm not going to go deep into it. So when you join for our courses, you can get to know the details of this. So optimizer, here we are using STD, and then the loss function, we are using different loss function here, cross entropy, and then the metrics, we are using the accuracy. So now I am going to build a model. So this ANN.fit is nothing but we say our model is getting built. Our model is being trained. So what to do? We have to pass the train data, X train data, and the Y train data, and then the epochs. Epochs means number of iteration. So we wanted to do in the five iteration. As you look at this, like the first iteration, see the loss function is 1.85, and then accuracy, see accuracy is only 33%. So as the iteration, as we keep on moving in the iteration, look at this, the accuracy is going to improve as it tries to learn, and then the accuracy keeps on improving. See, when we come to the fourth iteration, fifth iteration, the accuracy is 48 only. So this is not very good accuracy, because still the ANN whatever we have used, still it is, this accuracy is not good enough to go ahead and deploy this for production, right? So this is not good enough. Then we can use what we can call it as the now comes the now confusion matrix. Suppose if I want to use the confusion matrix, and then now I can use this prediction. I want to predict it. Now I have done the training, I wanted to predict it, then I pass the X test, and then I wanted to predict, and then get those classes for this particular prediction, and then I wanted to print this. When we get this report, like there is a, this is the matrix, there are many parameters here. Again, I'm not going to go discuss about all these things. So matrix is basically trying to give you like how good your model is. There are various factors like precision, recall, F1 score, and support. If you look at this like precision and all, so as far as the the images with the index 0, their precision is around 64%. And then I think the another one where we have the good precision is the image with 7, okay, class 7. So that is also having good precision. But still, this is not very good enough to say that this particular model is giving me a very good accuracy, right? So this is what we have used with the ANN. So now the same thing I want to use the CNN to build it. Now I wanted to use the same thing using the build, using this thing. So again, there is a step-by-step process, right? The step-by-step process. So how many filters we are going to see here? We are saying that you can use 32 filters, or you can give any value. You have to again experiment on all those things. So convolution 2D, what we are doing, and we are going to say the kernel size, like 3 by 3 or whatever the kernel size, right? That filter size. And then what kind of activation function you are going to use. In this case, we are saying that activation function, and what is the input size, right? Input size is 32 by 32, right? And this is how we are going to do. And then the max pooling. So max pooling, what is the pooling that size? Okay, that is 2 by 2, like this. So this is one particular layer. So again, we will go with another. This time the filters like 64, again kernel size, activation, max pooling. And then we are going to do the flatten. And then we are going to build a neural network with the dense layer. And in this case, the value, and the end layer, final layer is 10, because there are 10 classes only. So we are going to say 10. And then my activation is soft max, right? So this is how, when we say like we are going to build a model, or the network, the neural network we are going to build. In this case, it is a convolution neural network. And then you have to compile, and then we have used different optimizers and all, different loss functions, and then we start training. So here in this case, we are going to take 10 iteration. You can take any value. See, now again, if you look at this, when we start training, initially the accuracy is 0.46, and as we keep on, the loss function is around 1.48. Then the loss function, see here, keep on reducing. The loss function keeps on reducing. The accuracy keeps on increasing, and in this, to begin with, we got a good accuracy, right? So at the end of 5 epochs only, like epoch, we have got around 68%, whereas in the ANN it's around 40s only. So the accuracy is around 70 here. okay, which is significant improvement over ANN. So ANN are the best for image classification and gives the good accuracy. And also computationally very less compared to the ANN. So we as we know, like we have used the max pooling method. Right? Then we are going to evaluate. Then we are going to evaluate, pass the test data and see like what is the metric. So you can see here around 88%, right? So we are getting the good accuracy here. And then now we are going to predict what are the first five the images, right? Test, and then when I tested that thing, and then I'm going to compare with the actual predicted value. And then I'm going to get this array. Out of this, I want to take the maximum value. So then I will apply what is called as the max argument max, and then we are going to. So these are the first five are 58886, and then when we actually compare with the real one, see here, real one was 38806. So there is some error as far as these few values are concerned, but still it is giving around 35 out of 5. It has classified the properly, right? Then you can do the plot this images, right? So like this, we can go ahead with using the CNN compared to what is called as the ANN. Okay, so with that, in this session, just I wanted you to give a brief introduction about the convolution neural network, and then we have seen like how it is different compared to the ANN. What are the different operations we are going to do, like filtering, like pooling, right? All those operations we are going to do, and how the images would be classified. So if you are further interested, you can contact us, and you can reach out to us if you want to register for our course, and then we would be glad to accommodate you. It may be a weekend batch or maybe weekday batch based on your requirements. We should be able to do that. Okay. So with that, I formally conclude today's session. So hopefully this has given you a brief introduction about the AI, and then let us look at back the agenda, what we have started. Yeah. So introduction to what is called as the convolution neural network, and then how to build the CNN, and then just one image classification using the CNN. Okay, thanks for attending. Let me see any of the questions or anything here. Yeah. So Siraj is saying, yeah, back propagation is happening. Yes, back propagation is there. How does this differentiate alphabet 0 versus the number 0? Again, there will be a difference, right, between those two. And then you have how does the weight maintained in the CSS considering each layer. So the again, like here back propagation is there, right? So back propagation, what it does is this is another topic probably we should be able to cover in the next session. So when we use this particular what you can call it as the neural network, and as I told you, I had given an earlier example, like assuming that this particular work is given to the people, they wanted to identify whether this image is correct or not, then they are going to say, no, look, your weightage is something wrong. Please go back and do the calculation. Okay, that is what we call it as the backward propagation. What is the backward propagation is, like, for example, if you look at this, suppose some people give the different weight, they take different weight, and then they will say, yeah, this looks like the face of the animal, what we are looking for. So there is someone who is going to, we will see the error, right? So difference in the error, and if there is a difference in the error, we try to minimize the error. So that is what we call it as backward propagation. It is like giving the feedback. So it is like giving the feedback. Look, whatever you have done is not proper. Please go back and check your weights. Okay, adjust your weights or look back and then see whether the error is minimized. So that is what we call it as the backward propagation. So some people are asking about it. Yeah. And then we will see any other things. Yeah, recording will be provided to you. Yeah, recording will be provided to you. We'll be providing the recording. And then, so again, this is the Karthik is asking why 3000. Again, it is up to you. Like, how do you want to get started? So again, we are all exploring and experimenting on like what would be the ideal size. So this is just a 300,000 is just a particular number, and also again it depends on the number of features we wanted to use. And then Ajita Chakravarti sharing these notes or a location where we can, yeah, that would be done. Yeah, any position. Santosh is asking. Yes, it is. CNN is identifying the caller head in any position. Yeah. Then does not it identify 6 or 9 incorrectly? So the that is different. Like 6 is different, 9 is different, right? So you cannot say like if you invert 9 is a 6 only, right? So both are different, but the position in the sense like if the 9 is tilted bit right or left, or if you move it towards left or right, still it is able to identify. How many output nodes again depends on how many images you want to classify. So that is what is the output node. And yes, so it is a sparse connectivity. Siraj is asking, yes, to connect to the ANN, correct. Kernel is the edge detector, yes. Not necessary 3 by 3. Karthik is asking like convolution is the 3 by 3, not necessary. You can use any other matrix. It could be 2 by 2 or anything. That is also fine. Okay. Yeah, photo could be different angle. Priyanka and Sharma is taking. Yeah, that it is going to take care of that. In case of the CNN, it is going to take care. The same thing is not happening in case of the ANN. Okay. Okay, I think I have addressed most of the things. Yeah, is there any way to handle the exploding and grenade? Yes, there is a way. Thus, we can discuss like on those things once you join our course. Again, yeah, thanks for attending this webinar. So you can reach out to us. Okay, so hope this was useful to you. At least you get some idea about this. So this session is not to make you any, at least just to introduce you to few of the concepts so that you get the interest in this topic. So that is what the intention of this webinar. Hopefully it was fine for you people. And please join the tomorrow's session, and also we'll be taking a use case and we'll be going through this. Okay, so thanks again, and we will be putting up these videos also in our Facebook and then LinkedIn and other YouTube, and also you will be getting the through the mail also you'll be getting this. Okay, thanks very much, and see you tomorrow. Bye bye.